Hello. The purpose of this video is to provide you with an alternative way to factoring trinomials using the area model. I really like this method because I find it flows from everything we've been doing. So remember that we have been building our rectangles, our products for trinomials when we multiply them using an area model where we have length times width as our area model, and one side is the length and one side is the width. And when we multiply them, we get a rectangle, an area. Well, we're going to use this uh, concept, but this time the question is a bit different. The question is, what if I know the area and I need to find the sides? And this is exactly what we have. So come along, please, for these examples. We begin with x squared plus 7x plus 10. So if we recall the way we built our expansions, we'll remember that it looked like something like this. And we also recall that we had always the x squared term in this place and the independent term in this place. So that's our first step to factoring using the area model. Build our rectangle and place the first term, the x squared, on the top left and the independent on the bottom right. So now all we have to do is fill the other two spots by finding factors of the points that of the values that we have, keeping in mind that our midterm is 7x here. Yes. So let's start with that. So to factor x squared, that's pretty friendly. X multiplied by itself is x squared. And now I have to factor the 10. I can factor 10 in two ways. I can factor it as 5 times 2 or 10 times 1. You can probably see that in this case it's very friendly to do 5 and 2. So that's what I'm going to do. And because the 10 is positive and the 7 is positive, both numbers should be positive as well. So x plus 5 and x plus 2. And now let's expand these just like we did before. So if I multiply x times positive 5, I get 5x. And if I multiply 2 times x, I get positive 2x. And I can see very easily that my expansion is correct and that my diagonal adds to 7x. You can see that 5x plus 2x is 7x, which is my midterm. So that means the factors that I have as the outcome are x plus 5 and x plus 2. Of course, you can probably use a different method, and if you're comfortable with whatever method you use, that's fine. I'm just illustrating this method, and there's a reason for it that we will continue to explore later. So that is my first example, and this is the factoring. Now, keep in mind that every time we are factoring these trinomials, we are playing with a quadratic function, with a parabola. And basically what we're doing each time is going from standard form to factor form here. Yes? And that means we are able to identify the intercepts, the x-intercepts or the zeros of that quadratic. So in this case, the zeros are at -5 and -2. And we are doing this as we factor. So keep that in mind. So we're not factoring just for the sake of factoring. We're factoring with the purpose of finding intercepts. Okay, next example, x squared minus x minus 20. I'm just going to do the exact same process, build my grid, and I know that the x squared is going to fit here, and the minus 20 is going to fit here. Now, same as before, factors of x squared are just x and x because a number multiplied by itself, it's the number squared. And then I have to factor the negative 20. And of course, you can see that I can factor negative 20 in a variety of ways. Uh, However I factor it, one of the numbers have to be positive and the other one has to be negative because the answer is negative. So one number has to be positive, one is negative. And what gives me the clue as to the numbers that I might be looking for is the middle term of my um, trinomial, that negative x, negative 1x. Um, and of course, you can probably figure 5 and 4 are good numbers, just like we've done in other methods. They add up to, when you multiply them, you get negative 20. When you add, gives you negative 1. So let's try that. I have to be mindful that my diagonal has to add up to negative 1. So when I add the numbers in the diagonal, I need to realize that the bigger number must be negative, the absolute value. So I'm going to go with negative 5 and positive 4, because negative 5 times positive 4 gives me negative 20. So those are the factors that I chose for 20. And now I'm going to fill the rest of my model. So I have negative 5x here, and I have positive 4x here. And again, when I look at my red diagonal, I can see that if I were to do negative 5x plus 4x, my answer is negative x, which matches my midterm in my trinomial here. Perfect. So that's the second example. And you can see the factors are going to be x minus 5 and x plus 4. Cool. Now we're going to do one more example, and this one involves also positives and negatives. These examples are chosen because each of them is really different. So there is things that we have to think about each of them. So let's begin again here with our structure that we have been working with, and place the x squared and the 42 um, in the corresponding boxes. I realize that my factoring of x squared is x multiplied by itself. And I also have to analyze that, of course, I'm looking for factors of 42 that add up to negative 13. And the number that I'm getting is negative. Um, So that means that the addition is going to be negative. The product is positive. So that tells me that the only possibility that I have is that both numbers are negative, because when I multiply them, I'm going to get a positive. But when I add them, both being negative is going to produce me a negative outcome. So by now, you can probably figure the factors that I'm looking for are negative 7 and negative 6. Because you can see that negative 7 multiplied by negative 6 give me positive 42. Now let's finish the table and see what happens with our diagonal, our red diagonal, as it were. So here we go. We have these diagonal here, and I hope you can see that negative 7x added to negative 6x produces negative 13x, which is our midterm for the trinomial we were factoring. And that means that then our we have our factors, x minus 7, x minus 6. Very good. This is not dramatically different from the factoring methodologies you've learned, in the sense that we are looking for factors of the last term that add up to the middle term, right? And of course, maybe many of you may be thinking, well, I know how to factor these, thank you, which is good. Now, what about when we don't have the first term being a 1, the coefficient of the x squared? So let's look at this example. And well, this methodology, that's one of the reasons I like it. It works for any type of trinomial that is factorable. Let's keep that in mind. There's trinomials that we just cannot factor. But all of these are factorable. So let's begin the same way. We build our grid, and this time I'm going to put the 2x squared here because that's the first term, and I'm going to put the positive 10 here. Now, the difference really is that I have to factor the term that has the 2x squared. Now, in this case, it's very friendly. I can only do it in one way, which is 2x multiplied by x. And that gives me the 2x squared. And now I have to look at what are the factors of 10. Now, keeping in mind that I have a 2x there, that those factors that are going to give me the diagonal that I need, which is negative 12. So in this case, sometimes we might have to do a bit of trial and error and play with different numbers. But let's say that we choose negative 5. Now the outcome in the middle, if you notice, is negative. So I'm going to have two numbers that are negative because their product is positive. So let's try minus 5 or negative 5 and negative 2 and see what that does. I can see that negative 5 multiplied by negative 2 gives me positive 10, so those are the factors. Now, this is the part that sometimes we need trial and error to verify the diagonal. So let's complete the missing portion. 2 times negative 5, 2x times negative 5 is negative 10x, and negative 2 times x is negative 2x. Good. You can almost see now, if you haven't already, that our diagonal here works. In other words, negative 10x minus 2x produces a negative 12x, which is the midterm of our trinomial that we were intending on factoring. And when that works, we have our factors. So that's interesting because this was a bit different. And the methodology just worked the same. So my factors here are x minus 5 and 2x minus 2. And from here, I would be able to find the x-intercepts of these parabola, the zeros, and we also can term that as solving a quadratic equation like 2x squared minus 12x plus 10 equals 0. So all that happens in this context. So I hope that you see that even though the example is different, the methodology is just as effective. And we're going to do one last example to illustrate that. This example has, again, a different coefficient for the x squared, the trinomial we want to factor. So let's do that. Well, and if you can anticipate what we're doing and you want to pause the video and try it, hey, fantastic. That would be great. So we're going to do our area model, a rectangle, and I'm going to just do what I've been doing before. Place the negative 6x squared and the negative 8 where we know they go. And again, I have different possibilities for factoring the 6. I could factor 6 and 1. And then, of course, if I factor 6 and 1, when I multiply, I can see that at some point I might have to have a number that doesn't work for my middle, that I need positive 8. In this case, I also notice that the product, the negative 8, is negative. So I need one number that is going to be positive and one number that is going to be negative as factors that go to negative 8. I'm going to start by factoring the 6x squared like this. I'm going to do 3x and 2x. And again, this part may involve a bit of trial and error, but let's say that we agree that those are the factors for 6x squared. And then we're going to just do the factors of the 8. I can try -4 and +2. And if I do that, let's try that, -4 and +2. And then I can see that those are factors that give me -8. Now, what happens with the diagonal? If I do the diagonal in my top right square, I'm going to get -12x. And in the bottom, I get 4, +4x, which is going to give me -8. That's not going to work because I have +8. So all I have to do here is just change the signs. I'm going to make these +4 and these are -2. So I can tailor these as I need. So let's finish our space. So 4 times 3x will be +12x. And the bottom left is going to be -2 times 2x, -4x. And this time we can see that our red diagonal again that works, that we have 12x, +12x minus 4x equals +8x, which is what we were after. So that is our factorization for these trinomial. Again, we are also, and doing this process, these are my factors, right? 2x plus 4 and 3x minus 2. So I would, from here, find out the zeros for these quadratic. So I hope you follow this model. It's a very friendly model. And very importantly, you can factor any trinomial that is factorable using this area model. So if you're comfortable with another methodology, that's fine. Later, we're going to talk about what happens when we factor perfect trinomials. And we're going to connect these with another very important area of our course, which is completing the square. So that's why following this model is useful. So I thank you for watching, and we'll see you soon.